Hi there, we're going to do a couple little problems with polynomials. You may encounter some of these types of things. Anyway, let's just get going on this stuff. Find all the roots of the polynomial. B of x equals x cubed minus 7x squared plus 17x minus 15 if 2 plus I is a root. You have been given one root. That root is x equals 2 plus I. That is a complex root. So we know at this point in time that another root will also be the complex conjugate. So we change the sign on the imaginary component, making it 2 minus I. These two roots right here could be changed into factors. If I subtract 2, x minus 2 equals I. Then I can subtract I. X minus 2 minus I is a factor. We can do the same thing over here, subtract 2 and then add I, giving us x minus 2 plus I. We have two factors now. We can take these two factors and create a multiplication problem. One of the easiest ways to do that is to box these things up with a 3 by 3. Some people choose to distribute, and by all means, that is fine. This just works pretty well as far as organization is concerned. X minus 2 minus I, x minus 2 plus I. You do all this multiplication, we end up with an x squared, negative 2x, negative ix, negative 2x, positive 4, positive 2I, positive ix, negative 2I, and then a negative I squared. The negative ix and positive ix cancel. The negative 2I and positive 2I also cancel. Now, remember, I squared is negative 1. So this whole box right here is actually negative times negative 1. That is my I squared, giving us a value of 1. So this box is actually 1. If you take all this stuff and put it together, we end up with a trinomial, a quadratic. X squared minus 4x plus 5. That would factor x minus 2 minus I, x minus 2 plus I if you were to get the factors of that. Alrighty, well, we want to find all the roots. We have found two roots already, 2 plus I and 2 minus I based on the complex and its conjugate. So we need the last root. Well, we have our quadratic, which is the product of these two factors resulting from these two roots. So we can now divide it into x cubed minus 7x squared plus 17x minus 15. Polynomial long division. Let me slide up and make you a little bit of room right here. X cubed over x, first term over the first term, resulting in a value of x. Distribute that x to everything out front, giving us x cubed minus 4x squared plus 5x. We're going to come through with a sign change on that. Negative, positive, negative, and do the math. Bring everything down. That cancels. We get a negative 3x squared. Here we end up with a positive 12x, and bring down your negative 15, and you now repeat that first term. Negative 3x squared over your first term, x squared. Do the math. That reduces to a negative 3 value. Distribute that negative 3 to everything out front. Negative 3x squared, positive 12x, negative 15. Sign change it all. Remainder of 0, fantastic. That right there is our last factor. So if we were to write it as a factoring problem, we would have x minus 2 minus I, x minus 2 plus I, and x minus 3, but we do not want the factoring problem. We were asked for the roots to begin with. So those roots would be solutions 2 plus I, 2 minus I, and also a positive 3. Those are your three roots. Now we're going to be using the same type problem here. Well, excuse me. Same problem, different format. So here, I would like you to write a polynomial of least degree with integer coefficients that has roots 3 and 2 plus I. So if you were to check back and compare with the previous problem we just did, you're going to see that those are my roots. So knowing this, that we have roots of x equals 3, x equals 2 plus I, well, this is a complex root, so we should understand that the conjugate is also a root. So we can take these three roots and change them into factors. So get everything on the same side as the x. Here we would minus 3, giving us x minus 3. Here we will minus 2 and minus I, so x minus 2 minus I. Here we will subtract 2 and then add I, x minus 2 plus I. Those are my three factors. Now we need to change these three factors into a polynomial, so we need to make it larger. The way that we are going to accomplish that is through actual multiplication of these three. I will start here in a 3 by 3 box. You definitely can distribute to get this done. It will be x minus 2 minus I times x minus 2 plus I. We just did this previously, so x squared, negative 2x, negative 2x, positive 4. That will cancel. The negative ix will cancel with the positive ix. The negative 2i will cancel with the positive 2i in all those boxes if you fill them out. And here we get negative I squared, which is actually a positive 1. So coming out of all this, I get x squared minus 4x plus 5 again. Well, that was the combination of these two factors together, so we still have one more to deal with. So we need to multiply this times x minus 3. X cubed, negative 4x squared, positive 5x, negative 3x squared, negative 12x, negative 15. Put all this stuff together, combine like terms, x cubed. Let's see, we get negative 7x squared. Here we get a, what, positive? Oh, excuse me, negative times negative should have been my positive 12x right there. So I put those two together and get plus 17x minus 15. Make it a function. There you go. There is your polynomial of least degree, and this one is a function. Hope you had fun. Thanks.